Hi, hello friends. Good day wherever you are. So today I'll be making a video about network namespaces in the Linux kernel. So our network namespaces have become very important, especially in this age of cloud computing and containers, application containers like Docker. So what is a network namespace? So a network namespace is a logical copy of the network stack. So it's like virtualizing the network. So a network namespace in a Linux system, is an entity that has, its own routes. It has its own firewall rules. It has its own network devices. It has its own IP address and subnet. So you can think of a network namespace in the sense that if you have two applications running on the same system, application A and application B, you can have each application have its own unique network namespace. So application A will not have access to packets that belong to application B. We will not even see anything we don't see anything about it. So this is the concept that was used in the in technologies like Docker, and especially also in Openstack. Openstack make use of Linux network namespace a great deal, because you can use it to separate the networking of different tenants. So for example, in a cloud environment you can have different tenants. So for example, let's say we have tenant A and tenant B. Tenant A decides to use a network address of 10.10.10.0/24. Coincidentally, tenant B also decides to use the same subnet. So Openstack is able to achieve this, to make tenant A and tenant B use the same subnet by implementing the networking using network namespace. I will actually show you an example of this in our Openstack dashboard. So network namespace is actually not the only kind of namespace in the Linux kernel. There are 6 namespaces. We have for the process ID, we have for mount, we have for UTS, IPC, and for user. So without much ado, let's go to the terminal to look at some of the things we can do, because this is actually going to be a practical hands-on walkthrough. So I am on I have a server here. My server is actually an instance of the Openstack, but I'm running on it CentOS. So if you want to follow through this tutorial, you can use a recent version of the Linux OS, like CentOS 7, Fedora 24, or Red Hat 7, or Ubuntu 16. So all those should be fine. But here I'm going to be using CentOS. So to check if there's a namespace on a system, you can just run this command: ipns. So on this system I don't have any network namespace, but quickly let me show you how Openstack makes use of a network namespace. I have an Openstack installation here, and I have a couple of networks on my Openstack dashboard. So on the Openstack, you can see I have three networks. So I'm actually going to, if I go to my Openstack network node, So this is actually my Openstack network node. So on the Openstack network node, if I run the same command network ns, you see I have 3 network namespace, each corresponding to the networks that I have on my Openstack dashboard. So I'm actually going to add a new network on the Openstack dashboard. I'm going to call it blue or BlueNet, color blue. I don't know why I did that, but I'm just gonna call it blue. So okay, it's gonna be on the project admin. Create the network. Okay, let me. Okay, I am under the administrative task. Let me go under the project for this particular project. So I'm going to click on create network. I'm going to call this network BlueNet. Next, I'm going to create a subnet. So I am actually going to do something. I'm going to create exact same subnet like I had in my red network. So that is 192.168.2.0. Ordinarily, this should not be possible because I already have a network that has 192.168.2.0. But this is actually going to work because this is actually going to work. Oh, okay, sorry, I'm supposed to put my subnet name before I put my subnet itself. So there we have it. So the subnet name is BlueSub, or the network is 192.168.2.0. Click next and create. So it created another network named BlueNet with exact same subnet address network as my RedNet. This is possible because of IP namespace. So if I come back to the network namespace again and I run ipnetnest, you see I have an additional network namespace that was not there before. Before I had 3, now I have 4. So that is the power of network namespace. It allows Openstack to logically separate networks from each other. So let's move ahead. Let's do something more. Let's actually, so I am on my CentOS server right now. I have moved away from the Openstack network node. I am going to create my own network namespace. So for you to do that, you can do network ns hard. So I'm going to call it RedNet, or let me choose a new color just for the sake of it. I'll call it PurpleNet. So I've added a new network namespace called PurpleNet. So when I run ipnetns again, you see I have PurpleNet show up. So what can we do on this this network namespace? We can go inside of it and we can execute. So if you need to execute something under this network namespace, we go inside of it and we can run IP address. So PurpleNet, this PurpleNet, you have to get that right. So you see the network namespace has its own look back interface. So let's run it again. You see, So what can we do? We can actually bring up this loopback interface, because right now it is in the down state. So we can say under the purple network namespace, we can say IP link set hello up. So we brought the interface up. You see, the interface is up with an IP address of 127.0.0.1. Even though on this system, you know, in the root namespace, we have an interface, also a loopback interface with an address of 127.0.0.1. The network namespace has its own copy. You know, it has its own copy of the loopback interface with the same address. So I hope you are following me so far. Or if you have any questions, you can put in the comment section. So what else can we do? We can actually let's create a new link. Right now on this machine, I have just 2 links. So we can create what is called a vit pair. So what is a vit pair? So let me quickly give you a run through of what we mean by vit pair. So vit pair is actually 2 interfaces that act like a pipe. So whatever comes in one interface will come out at the other end, and whatever comes in at the vit1 will come out at vit0. So it's like a pipe where where the traffic can flow either way, and whatever comes in at one end must come out at the other end. So we're going to create a vit pair. So, and to create a vit pair, we say IP link add. So we have to specify the type of so we first have to specify the name. So we call it vit0, just to indicate that it is a virtual Ethernet 0. So we give it a type. It's going to be of type vit. So we have to specify the peer name, you know, the other end of this pipe, vit1. So if we do IP address again, we see we now have 2 interfaces on the root. So this is still on the root namespace. So the root namespace is the default network stack that we have, so which is different from the namespace that we created. So this is the purple net. So now that we have these 2 interfaces, I'm going to add one of the end of this pipe. I'm going to add it. I'm going to move it to the new namespace. So we can achieve that by running IP link set vit1 namespace, or we set it to the purple net. So if we run IP address again, you see now we only have the vit0. The vit1 has been moved to the purple net. You see now under the purple net namespace we have this vit1. So the vit1 is still in a down state. So we can do something about that. We can give it an IP address. So we create a new subnet. We can say so. Right now I'm using. Remember the exec. When you want to execute something under a namespace, you use the exec keyword here. So I will use the ifconfig vit1 I'll give it 192.168.3.1/24, and I'll tell it to bring it up. So if you run IPA under the network namespace, you see now we have vit1 has an IP address of 3.1. So we have to give vit0 also an IP address. So to do that, remember we have the vit0 under the root namespace. So give vit0 an IP address. I have config vit0 192.168.3.2/24 up. We bring it up. If we run IP address on the root namespace, we see now we have the vit0 have an IP address. So let's go back into our network namespace. So you have to remember the exact keyword, the namespace name. So the command that we want to run. Now we want to ping the other end of this pipe that we created. Remember I said whatever comes in, whatever goes out from one end of the pipe must come out. So this is exactly what happened. I ping the other end of the pipe and it's responded. Let me ping the vit0 address and it's responded. So let's do something more, a little bit more advanced, a little bit more complex. So under our namespace, we can ping the other end of the vit pair, but can we ping an address that is outside? That is outside a network address? No, we can't. It says the network is unreachable, even though in the root, if we ping this IP address ordinarily or from this server, it responds. But if we ping it under the new namespace, it will not respond. Why? Because we don't have a route to it. So under the namespace, we can run this command IP route. So the only route we have is the route to the 3.0 network. So we can add a route under our namespace. We can add a default route specifically. So we say IP route add route IP route add default via 3.2 dev is 1. So we are adding a new route under the namespace via the other end of the vit pair. So we had it. So if we execute our IP route again, now we have a default route. But let's try to ping the 8.8 again. We cannot ping it. Yes. So there's a reason for that. The reason for that is because we need to enable packet forwarding on this system, because by default, like I said, the namespaces are completely different, segregated from each other. Ordinarily they won't communicate until we enable packet forwarding. So how do you enable packet forwarding? You can do that by echo 1 into proc net IPv4 IPv4 let me get the exact parts for this, forget it sometimes. So it's a proc 6, yeah, that's true, it's proc 6 net IPv4 IP_forward. So let me clear my screen to make it clearer. So what I'm about to do is enable packet forwarding on this machine, so that packets can be forwarded. So essentially I'm turning this server into a router. So I did that. So if we did a cat, and so now we see it has a value of 1. So we enabled forwarding. Let's try to ping again, if it's gonna work. Yeah, it's not working again. So what else do we need to do? So one thing that we still need to do is called masquerading. We have to enable masquerading on our firewall, because I have on my system, I have the firewall, this service is running. I'm using for firewall. So there, if we do firewall cmd get zones, so I have the zones. So the zone that we need to enable masquerading on is the external zone. So we have to, so if we on the external zone, let's check it. We'll say zone equals to external. We'll list all. Maybe it's already enabled by default. Let's check, and yes. So on this machine it is enabled by default. So masquerading is enabled. So if it was not enabled, we can actually enable it. All we have to do is say zone external add masquerade. So it told us that masquerade it's already enabled. So what other thing do we need to do? We need to add our vit peer. We have this vit 0. We have to add it to a particular zone, because right now it doesn't belong to any zone of the firewall. So what we have to do is we say firewall cmd change interface. The interface is v0, and we want to put it in zone internal. So success here. So let's try the ping again. Okay, still not working. So let's see what's going on here. We've turned on the masquerade. Let's see firewall command. Let's get active. So okay, these are the active. So yeah, I think what I need to do is to move my ETH0 to the external zone. So right now I can change my port on ETH0, because that is going to be our gateway to the external world. So I moved it. So let's see, and yeah, we're successful this time around. So I hope you see what we have to do to make that happen. I had to move my, so if I say get active zones, I have to move my ET0 to my external and move my my vit peer to the internal. The external zone is the one that has the masquerading enabled. So and that is what will make it work finally. So we can, so from this we can ping the external world. We can ping the IP address. I think we should be able to ping the IP address of the ETH1 192.168. .1.1, and yes, we can ping it. So I hope I have informed you. I hope I have enlightened you a little bit on the importance of the network namespace. The network namespace was introduced in kernel 2.6.24. And one other thing I can show you is this. There's a folder or directory var, that's var run and it. Yes. So the namespace that was created was actually stored under this directory. So if we delete the namespace, this file is going to disappear, and we can actually create another namespace. Let's say yellow namespace. I like to use color namespace. Also, we have to put the keyword hard. That is what we are trying to do. We are adding. So if we look at the directory again, the yellow namespace has appeared. So thank you for watching. If you hear somebody crying under the video, that's my son. We're trying to get him to put on his clothes. So that's a child's word for you. So yeah, thank you for watching, and if you have any questions, put it under the comment section. I will try to answer, and if you think there's something else I need to cover the topic, you can suggest it. Thank you for watching. Bye.